Question 7a, we have to show that the equation tan x plus cos x upon tan x minus cos x equals to k, where k is a constant, can be expressed as k plus 1 sine squared plus k minus 1 sine x minus k plus 1. Now, whenever we have to prove any equation, any trigonometric equation, we'll start off by using any of the identities that we know. So now we know that tan x can be written as sine upon cos. So before we do that, we can first cross multiply. So this can be written as tan x plus cos x. That will be equals to k tan x minus k cos x. So in place of tan, we can write sine upon cos, and I will just use S and C for sine and cos and T for tan. So this will become sine upon cos plus cos is equals to k sine upon cos minus k into cos. Taking the LCM on both the sides, we'll get sine plus cos squared upon cos, and this will become k sine minus, so this will become k cos squared upon cos. The cos in the denominators will cancel out. Now, as we have to bring our equation in terms of sine, so we can use 1 minus sine squared in place of cos squared, and this will become k sine minus k into 1 minus sine squared. Now, expanding as we have to make a quadratic equation, so this will become sine plus 1 minus sine squared is equals to k sine minus k plus k sine squared. Now bringing the equation, the complete equation on the right hand side to keep the sine squared positive. So this will become k sine squared. This minus sine squared will go on the right hand side and become a plus sine squared. This plus k sine will remain as it is. This will become a minus sign. This is a minus k up here, and the plus 1 will come on this side and become a minus 1. Now taking sine squared common over here, so that will be equals to, when we take sine squared x common, so this will become k plus 1. Taking sine common from over here, this will become k minus 1. And if we take negative 1 common out over here, so this will be written as k plus 1 equals to 0, which was the value that we had to prove, the expression that we had to prove. Now in part B, it says, hence solve the equation tan x plus cos x upon tan minus cos equals to 4. Now we know that the equation that we solved was for equals to k, and now in place of k we have 4. So this equation that we got in the previous part, which was sine squared into k plus 1, we'll replace the k with the 4 up here. So this will become 4 plus 1, 5 sine squared of x. So I'll just write it up here. This is k plus 1 sine squared of x, and this was plus sine plus k minus 1 into sine of x, and this was minus into k plus 1 equals to 0. So k plus 1, so as we now know that k is equals to 4, so this will become 5 sine squared of x plus, so that is 4 minus 1, which will become 3 sine x, and minus, so this will be 5 plus 1, 4 plus 1, so that will be equals to 5 equals to 0. Now we can try and do middle term breaking up here, but as it cannot be applied, so we'll have to use a quadratic formula. So sine x will be equals to minus b. So minus b is 3. So this will become minus 3 plus minus b squared minus 4ac. So b squared will be 3 squared minus 4 into 5 into minus 5 and divided by 2a. So 2a will be 2 times 5. Simplifying this, we'll get sine x will be equals to minus 3 plus minus, so 3 squared is 9, and 25 times 4 will become 100, and that will become a plus sign. So this will be 100 plus 9 upon 10. Now taking the square root of 109, so we'll get sine x will be equals to, so minus 3. So square root of 109 will be equals to 10.44. So this will become minus 3 plus minus 10.440 divided by 10. So we can write sine x will be equals to minus 3 plus 10.440 upon 10. And sine x can also be equals to minus 3 minus 10.440 upon 10. So minus 3 plus 10.440 divided by 10, that is equals to 0.744. So sine x is equals to 0.744. And in this case, it will be minus 3 minus 10.440. Dividing it by 10, we'll get 1.34 minus 1.34. But as it is greater than 1, or it is less than minus 1, so sine inverse of this will not be possible. So we'll ignore this. Now taking sine inverse of 0.744, the basic angle will be equals to, so shift sine inverse of 0. And we have to make sure that our calculator is now in degree mode. So this will be shift sine inverse of 0.744. The basic angle will be 48.07. And as the sign is positive, so we'll take the values of x for sine in the positive quadrants of sine. So sine is positive in the first and the second quadrant. So we'll make the basic angle 48.07 in the first quadrant, and in the second quadrant, once we have the basic angles, now we can find x. So the first value of x will be 48.07. And the second value of x will be 180 minus 48.07. So 48.07, that will become 48.1 degrees. And 180 minus, so 180 minus 48.07, that is equals to 131.93. So the final answer will be 131.9 degrees.